We'll start with the, as we have completed yesterday, the second shifting theorem and its properties and also the examples based on it. So now we will start with the problems on the uh, periodic functions. So as yesterday we just told you, I explained you that if a function of the form f of t plus p is equal to f of t, then we call this function as periodic function with the period p. So more detail about the periodic function, I'm actually I've done one video and I'll be uploading it in that YouTube. Just go through that, okay, if you want more details about it. So for your syllabus, only the definition and the examples are there. I'm dealing it here. So here, when you have the periodic function, then how one can solve the Laplace transform of those particular functions? That is the question. Let's see. The first problem here is find the Laplace transform of the following triangular wave function. So actually this is the triangular wave function. So it is defined in this way. And we will start with the calculation of the Laplace transform of this particular function. And clearly it is given that f of t plus 2 pi is equal to f of t. So you can verify here, in place of p, just f of t plus p is equal to f of t, as the definition of periodic function says. So in place of p, what do you have? Here you are having p is equal to 2 pi. So this implies this triangular wave function is the periodic function with the period p is equal to 2 pi. That's the meaning. Okay. So now let's use the formula for it. So the formula for finding out the Laplace transform of the periodic function is L of f of t is equal to 1 upon 1 minus e to the power minus sp integration from 0 to p e to the power minus st f of t dt. So this is the formula. So here clearly they have given that the period is 2 pi. So this is equal to, now we will apply this, which is equal to 1 upon 1 minus e to the power, this p is 2 pi. So p is 2 pi in the sense what it is? It becomes minus 2 pi s. P is 2 pi. Integration from 0 to 2 pi e to the power minus st f of t dt. Now clearly you know that this particular function is defined as t within the interval 0 to pi, and it is defined as 2 pi minus t within the interval pi to 2 pi. So we have to split it. So what we do now here, we will take this 1 minus e to the power minus 2 pi as completely out. So if I take that completely out, this is equal to 1 upon 1 minus e to the power minus 2 pi s completely out. So here I'll be splitting the limits from 0 to pi and then from pi to 2 pi. So first I take 0 to pi. 0 to pi e to the power minus st f of t into dt plus integration pi to 2 pi e to the power minus st f of t into dt. So this is the, like split. So now what we do, we know f of t in the interval 0 to pi, it is given as t, and we know the function f of t in the interval pi to 2 pi, that is given as 2 pi minus t. Now substituting these values, okay, I'll just clear this. Now by substituting that, this will be again 1 upon 1 minus e to the power minus 2 pi s as it is. This will be equal to, here integration 0 to pi e to the power minus st into t dt. Next term is pi to 2 pi e to the power minus st 2 pi minus t into dt. So this is the function split. Okay. So now you can just use the differentiation formula which I already been taught you. So in this particular integral, what I do, I take t for differentiation and e to the power minus st for the integration. Here t differentiation is 1, 1 again for the differentiation is 0. Similarly, this integration is e to the power minus st upon minus s. Further integration is e to the power minus st upon s square. We should stop at this point. So cross multiplying with the positive and negative sign. So what I get here, the first term, this I keep as it is 1 upon 1 minus e to the power minus 2 pi s. This integration is minus t into e to the power minus st upon s. Then this 1 into this is just minus e to the power minus st upon s square. So this is from 0 to pi. So big bracket you can make it. Similarly for this integral, for differentiation I'll take this 2 pi minus t for differentiation, and this e to the power minus st for the integration. So again differentiate this. This is minus 1 because 2 pi integration, so 2 pi differentiation is 0, it is just minus 1. Again differentiation, it is 0. Similarly here it is e to the power minus st upon s, e to the power minus st upon s square. Okay, so once we have done with this, again cross multiply with positive and negative sign and take the required integration. So here this plus, I'll write it here, this will be equal to minus 2 pi minus t into e to the power minus st upon s, and this minus into minus it will become plus here e to the power minus st upon s square. Okay, so this is from what, 0 to 2 pi. So now this is what this step is done now. Okay, so we have taken the integration and we have taken the integration of both the terms within the limit 0 to pi and pi to 2 pi. So once we have done with this, now simple substituting the values, upper limit and the lower limit. So what we do then? So here in this step you can observe, here wherever t is there, I first apply pi. So this left side you can keep as it is, that is 1 upon 1 minus e to the power minus 2 pi s, it is as it is here. Okay, just a moment. Okay, I'll get little more space to write. Okay, so this, I think the whatever I've written is visible, right guys?
Yes, ma'am.
Okay, so this will be equal to, now if I apply pi, so if I apply pi, this will become minus pi e to the power minus s pi upon s, and this again pi, if you apply, it is minus e to the power minus s pi upon s square. So this term you observe. Okay, then similarly lower limit, if I apply lower limit t as 0, this term will be 0 completely. This will become minus of minus, that will become plus e to the power, so 0 divided by s square, I'll directly write it as 1 upon s square. Okay, so how I got 1, e to the power 0 will be 1 divided by s square. Okay, so this is, this 3 term is about this particular limit. Now next come to this. This will be, if I apply 2 pi, so 2 pi minus 2 pi, that is this first term will be 0. Only next term is remaining, e to the power minus 2 pi s divided by s square plus e to the power minus 2 pi s upon s square. Second term you can see, now this pi is over. If I apply pi, so minus of minus it becomes plus, 2 pi minus pi is pi. So plus pi into e to the power minus s pi upon s, plus again this is, if I put pi, e to the power minus s pi upon s square, e to the power minus s pi upon s square. Okay, so this is what, sorry, here it is plus, so it will become minus here, because upper limit minus lower limit, already plus is there, so minus it will become lower limit. Okay, so now we have substituted all the values. Now simplification you have to do. So what we do here, simplification, you can see minus pi e to the power minus s pi minus plus pi e to the power minus s pi, these two I'll cancel. Then what is remaining then? Here you can see e to the power minus s pi upon square minus e to the power minus s pi upon square means it is minus 2 times of e to the power minus s pi upon s square plus 1 upon s square plus here what is remaining, e to the power minus 2 pi s upon s square. So all these are s square, so I can rewrite this as 1 minus 2 into e to the power minus s pi plus e to the power minus 2 pi s divided by s square. Actually this term is there here, 1 upon 1 minus e to the power minus 2 pi s, this is there. Okay, so the finally you can just see that it is in the form of a square, this I can write as e to the power minus pi s the whole square, so b square, because you know a to the power m to the power n is what, a to the power mn. So e to the power minus pi s to the power 2 is e to the power minus 2 pi s. So this is a square plus b square minus 2ab, means a minus b the whole square. So 1 by s square, 1 minus e to the power minus s pi the whole square divided by, this s square is down only, okay, so this is s square into this one. You can observe down, it is 1 minus e to the power minus 2 pi s. So this can be written as 1 square minus e to the power minus pi s the whole square. So it is what, a square minus b square. So this implies a plus b into a minus b. I can write down it as a plus b, a minus b. So here 1 minus e to the power minus s pi I can cancel here with this. So what I have left then? 1 minus e to the power minus s pi upon s square into 1 plus e to the power minus pi s. So this is the final answer. Did you follow this question, guys? All of you?
Yes, ma'am.
Remaining all? Yes. If you're not able to switch on your mic, at least you can chat it in the box so that I will continue with the next example. Okay. So now this is the same example if you're observing. So in place of pi, I am having here a. That's it. It's remaining all is same. So you just take this example and do it yourself. Same as above. So just in place of pi, you are having here a. That's it. Okay. The second example is same, that you will be trying. That is for practice problem. Example number 8. Let me take the next example. Find the Laplace transform of the square wave function. Sometimes they may not mention the square wave, they may not mention the triangular wave. Just they'll give that find the Laplace transform of the following function. Also they may give. So I'm just telling you that how the functions looks like. The square wave function looks like this. So it is defined as f of t is equal to 1 if t lies between 0 and a, and it is equal to minus 1 if t lies between a and 2a with the period 2a. So this is given. So let's start with the problem. Here this is the given function and the p is given as 2a. Now we have the period p is equal to 2a. Now we know that Laplace transform of the periodic function is given by 1 divided by 1 minus e to the power minus ps integration from 0 to p e to the power minus st f of t into dt. So wherever p is there, apply 2a. This will be equal to 1 upon 1 minus e to the power minus 2as. Then integration 0 to 2a e to the power minus st f of t dt. Now since this function is splitted into 2, that is between the interval 0 to a and from a to 2a, we'll write this as 1 minus e to the power minus 2as. This I keep completely out. This is from 0 to a e to the power minus st f of t dt plus from a to 2a. Again e to the power minus st f of t dt. So this is how we'll be splitting. Now we will write f of t function between those interval. So this is equal to 1 upon 1 minus e to the power minus 2s as it is 0 to a. Within 0 to a, my f of t is defined as 1. So it is just simply 1 into dt. Similarly, between a to 2a, e to the power minus st minus 1 into dt. Okay, so this is how we split it now into 2. Now we will integrate it. So it's simple integration, guys. If you see, this is just e to the power minus st. It is, if I take this minus sign here, it is just e to the power minus st. So let's do it. So 1 upon 1 minus, this is not here, e to the power minus 2 pi s. This will be e to the power minus st upon minus s integration. This I'll take a big bracket from 0 to a. Similarly, minus I will do. This minus sign I am taking out. So this will be e to the power minus st upon minus s. Again from what to what? It is from a to 2a. Okay. So this is equal to 1 upon 1 minus e to the power minus 2 pi s. So here, if I apply the upper limit, it is minus e to the power minus sa upon s. Upper limit, if I put t is equal to a. Then lower limit. So this is just minus of minus plus e to the power 0 is 1. It is just 1 upon s. Similarly, this term, if I put 2a, since it is minus here, minus and this minus, it becomes plus. So e to the power minus 2as upon s. and minus into minus plus one more minus of lower integral, that will become minus a to the power minus sa upon s. So this is what we will get, okay, for both the upper limit and lower limits. So now just check, anything we can cancel or anything we cannot, then no problem. We can write this as 1 upon 1 minus e to the power 2as. This is e to the power minus sa, e to the power minus sa is 2 times. So just write this first one minus 2 times of e to the power minus sa, this is s again, here it is s again, then plus e to the power minus 2s upon s. So the you can just see that in the denominator it is s, so I can just write it as 1 minus e to the power minus 2as into s, I'll write in the denominator, and in the numerator it is 1 minus 2 times of e to the power minus sa plus e to the power minus 2as. Again, as in the previous example, you can observe it is in the form of a square. This we can write it as e to the power minus as the whole square, that is b square, and this is your 2ab minus 2ab. So we can write this as a square minus a square plus b square minus 2ab. Okay, so I can rewrite this as, just see, this is 1 minus e to the power minus sa the whole square divided by s into denominator. How do we write this? This one, 1 minus e to the power minus 2s can be written as 1 minus e to the power minus s the whole square. So this is a square minus b square. So 1 minus e to the power minus as into 1 plus e to the power minus as. So like this we can split it into 2. So it is 1 plus e to the power minus as, 1 minus e to the power minus as. So 1 e to the power minus s we can cancel with this. So what we are left is 1 minus e to the power minus sa upon s into 1 plus e to the power minus as. Okay, so this is how you're supposed to solve this variety of example. Hope you are following this, guys. Yes?
Yes, ma'am.
Okay, so now let's see the next example. Here, find the Laplace transform of the sawtooth wave function. Actually, the names are a little funny, but these are actually important functions when you study the wavelet theory. So here it's a sawtooth wavelet function, which is defined as f of t is equal to kt, where t is lying between 0 and 1 with the period 1. So here p is given as 1. So it's a simple function. They've given f of t is equal to kt. So simply directly you start with the Laplace transform, and you just, I want you have to solve it meanwhile with me, guys. So just take, I will also be solving it, you also will be solving it simultaneously. Let's see if we will solve it first. Let p is equal to 1. Hope you all are solving now. Take the function and start solving with me. I'll be also solving it. So Laplace transform of f of t of the periodic function is given by 1 minus e to the power minus ps integration from 0 to p e to the power minus st f of t dt. So this is equal to, since p is equal to 1, this will be reduced to 1 minus e to the power minus s. This is from 0 to 1, e to the power minus st. F of t is here kt into dt. So this is equal to, since k is constant, I'll just take it out. It is k divided by 1 minus e to the power minus s. Then integration of e to the power minus st into t dt. This is what is the function now. So I can just use for differentiation and integration rule. So as we used to it, t, and this we use it for integration. So this is differentiation is 1, this differentiation is 0. This is e to the power minus st upon minus s. It is e to the power minus st upon s square. This is how we solve it. This is plus and minus. So here we will be getting k upon 1 minus e to the power minus s. This is t into minus t into e to the power minus st upon s. This is minus e to the power minus st upon s square from what we do, from 0 to 1. So we are applying the values from 0 to 1. Okay, so if I apply upper limit, so it is k divided by 1 minus e to the power minus s. So if I apply t is equal to 1, this will become simple. This is minus 1 into e to the power minus s divided by s. So it is minus e to the power minus s upon s. And if I apply again here 1, this is just e to the power minus s upon s square. Lower limit, if I put 0, since t into is there, so this term will become 0, and this term will become minus of minus plus 1 upon s square. Okay, so this is again k divided by 1 minus e to the power minus s, guys. This will be, since here you can see, don't just write it dumbly, you have to see in the denominator all are s square or all are s, you have to check correctly. So here if you see clearly, it is s here, it is s square here, it is s square here. If I take the LCM, s square is the LCM, so here s is missing, so I have to multiply this with s. So that I'll get here minus s e to the power minus s minus e to the power minus s plus 1 divided by s square. Okay, so this term will get now. So finally, what you, whenever you are writing the answer, it is simply, the answer is k into 1 minus e to the power minus s into e to the power minus s divided by s square into 1 minus e to the power minus s. Okay, so this is the final answer for the sawtooth wave function. Okay, so like this you have to solve the examples based on the periodic function. Let's see the next example. Here in this example, find the Laplace transform where f of t is given as sin t for t lies between 0 to pi, and it is 0 if it is lying between pi to 2 pi with the period 2 pi. So it's they have given that there is a periodic function, sine is a periodic function with the period 2 pi. So let's start with the problem. Okay, so given that what is p is equal to? P is equal to 2 pi. Okay, so we will write the Laplace transform of the periodic function. So what is p here? It is 2 pi. So Laplace transform f of t, that is 1 minus e to the power minus 2 pi s into, so we have to split into the 2. In fact, I'll write it one more time. It is 0 to 2 pi e to the power minus st f of t dt. So since my function is split into 2, that is between 0 to pi and pi to 2 pi, we rewrite it as 1 minus e to the power minus 2 pi s. This is equal to 0 to pi e to the power minus st into sin t dt. Then plus, since the next function is 0 anyways, I'll write it pi to 2 pi, that is 0. Okay, because e to the power minus st f of t is 0, so this term will become 0. So we have to bother only about this function now. So again, if you remember, guys, in the first Laplace transform function, I solved one of the Laplace transform of sin at by using this particular formula. The same way I'm going to solve this now. So let me consider this I is equal to integration from 0 to pi e to the power minus st sin t into dt. Because with our usual tricks we cannot do it, because sine we cannot differentiate up to 0, and this e to the power neither this e to the power minus st, so we cannot apply that trick. So we will use this particular method. Let us consider I is equal to this, and I told you easy way to remember the integration of by parts. So if you know that, still I repeat it, that is, if say d by dx of u into v is what? U dash v plus first derivative, a second function as it is, second function as it is, first function as it is, the derivative of the second function. Now integrating both the side, what we get? It is just uv is equal to integration of u dash v plus integration of uv dash. But I want this. So integration of u dash v will be equal to uv minus integration of u into v dash. You have to remember this. So this I'm going to utilize. So in this particular function, first I need to identify what is my u and what is my v dash. So here clearly you can see that in this particular function, here in this equation, or down once again I have written here. So here in this function I will consider my u dash. This is equal to e to the power minus st, and this implies what is u is equal to, by integrating this, it is e to the power minus st upon minus s. Similarly, v dash is no, not known to us. So v, but I know v is sin t here. So differentiation of sin t is cos t. So this is how I know u dash, v dash, u and v. So apply in the given formula. So if I apply that in the given formula, you can just check here. This is my u, this is my v, minus integration from 0 to pi. This is our u and this is our v dash. So again, if you just simplify, you get minus e to the power minus st sin t divided by s. Minus into minus it becomes plus. This s I have taken out. It is 0 to pi e to the power minus st into cos t dt. Again, this will be repeating. So again, here also we have to use this particular formula. So in this example, here it is u dash is e to the power minus st and v dash is minus sin t. Actually, minus sin t, I will just tell you how I got this. But what is my v? V is cos t. Differentiation of cos t is v dash, that is minus sin t. And you will get by integrating this. So in this way, we have got again u dash, v dash, u and v. Again, substitute in this equation. So this term I am keeping as it is. 1 by s I am keeping as it is. Again, this is u and this is v minus integration from 0 to pi. This is u and this is v dash into dt. Okay. So now again, if you just simplify this, guys, here you will be getting this term is repeating. In the next step, you can see that this is repeating e to the power minus st into sin t. So this is nothing but your I. So you can take this whole term on the other hand. This will become I plus 1 upon s square into I. The remaining terms you can write it here only and apply the limit from 0 to pi. If I apply pi here, upper limit, sin pi is 0. So this whole term will become 0. And here this is minus 1 upon s square e to the power minus s pi into cos pi. Then again minus of minus plus lower limit. This, since it is containing sin 0, this will become 0. This term will become e to the power 0 is 1, cos 0 is 1. It simply becomes plus 1 upon s square. Okay. So here you can see on the other hand, you are able to see that it is s square plus 1 upon s square into I. And here what you are getting? This is just this term. Yeah, this cos pi is minus 1 minus into this. It becomes plus e to the power minus s pi upon s square plus 1 upon s square. So here what you are writing, this is nothing but this term I am taking on the right hand side. So this will become e to the power minus s pi plus 1 divided by s square into s square upon s square plus 1. So this s square will cancel. What you are left with is, now this is the I. This is I means this is what I have got. This is what I have got, this value I have got. So now I will start with again the periodic function value. So it is 1 upon 1 minus e to the power minus 2 pi s into this value. So this value is known to us. This is the value. Okay. So I'm just substituting here. This will become e to the power minus s pi plus 1. Again, you all know that this we can write as a square minus b square. So a plus b into a minus b. So 1 e to the power minus s pi will cancel. You're just getting 1 upon 1 minus e to the power minus pi s into s square plus 1. So like this you can solve the even difficult level of problems. So this is the Laplace transform with respect to the periodic function sin t. Okay. So this is how, guys, you're supposed to solve the problems. So let me see the next example here. So this is a simple example. Find the Laplace transform of f of t is equal to e to the power 2t if t lies between 0 and 1 and it is taking the value 0 for t greater than 1. So what we have here is, so clearly Laplace transform of f of t we need. So 0 to infinity we take, because they have not given any period here. So they have not mentioned any period. So what we do, just we will take splitting the function 0 to 1 and t greater than 1. So 0 to infinity e to the power minus st f of t dt we will take. From 0 to 1 it is defined, but from t 1 to infinity it is 0. So I'm not taking that function. So from 0 to 1 it is e to the power minus st into e to the power 2t dt. So simple, just integration of e to the power minus of s minus 2t divided by s minus 2. Okay, applying the limit 0 to 1. If I apply 1, this will become e to the power minus of s minus 2 upon s minus 2. Then if I apply 0, this will become just plus 1 upon s minus 2. So since s minus 2 is common both the side, you can just take this as 1 minus s minus 2 divided by s minus 2. So this is just the answer. So these questions, if at all appear, it may ask for 2 to 3 marks. Okay. So this is how you're supposed to solve the examples on the periodic function. So here I think some examples I've given. 12th, 13th, 14th example is for your practice problem. Try to solve these examples. And here again, this example you can see, guys. So this is a simple example. They've mentioned that f of t is e to the power t and the period is given as 2 pi. So here just simple function, apply the limits where p is 2 pi, 1 upon 1 minus e to the power minus 2 pi s, integration from 0 to 2 pi, e to the power minus st, f of t is e to the power t into dt. So this is equal to, again this inside, if you will see, this will become e to the power minus s minus 1 into t dt. Simple integration of this, you integrate it, apply the limit 0 and 2 pi. If I apply 2 pi, this term will be getting, and if I apply 0, it is minus of minus plus 1 upon s minus 1. So clearly you can rewrite this as in this way. So this is how, guys, you are supposed to solve the problems. This question may be asked for 2 to 3 marks. Okay, so example number 14. So similarly, you can see these are the examples. Again, you're supposed to solve by using the periodic function. So these are for practice problems, guys. So all practice problems you are supposed to solve it very clearly. So this is another example. You just go through this example. Okay, so this I have already solved. You go through once again. If you feel difficulty in understanding any step here, you can ask me. Just I'll orally explain you. So same thing. Here it is t within the interval 0 to pi, and it is pi minus t within the interval pi to 2 pi with the period p is equal to 2 pi. So apply the periodic function formula, and here you can see that this is the integral with e to the power minus st and t. This is the integral with e to the power minus st and pi minus t. So use our trick method. So this is for differentiation, you take t. For integration, you take e to the power minus st for the first integral. Similarly, in the second integral, you can take e to the power minus st for the integration and pi minus t for the differentiation. Okay, so then again simple integration by using this trick, then applying upper and lower limits and solving. So when you are solving, what is important is just understand, try to write it in the form of a minus b the whole square, and try to write the denominator in the form of a square minus b square. Then only you can eliminate maximum terms in that. Then only you can just get a smaller unit of function finally. Otherwise it will become bigger one. So just that is what is important when you are doing this problems. Okay, so these are the actually problems, guys, which are based on the periodic functions. So try to solve all the examples, okay, in detail. And I have given each step. I have not omitted any single step here. Even plus minus also I have counted, because you can solve it easily. Okay, so